Okay, so we've looked at how many signals we get, and then we looked at where those signals could be found on the graph. Now we're going to look at what the area under each signal tells us. And this is going to indicate the relative number of protons making the signal. So we'll get integration values like this: 27, 42, 28.4, and 42.2. Note that these three are considered to be one signal. These are considered to be one signal, and these are considered to be one signal. And kind of obviously that one is one signal. So we get these kind of random numbers. What you need to do, these are relative values, and we'll divide all by the smallest and then multiply to get whole numbers. So the smallest number here is 27, so we'll take 27, divide by 27, of course get 1. We get 40.2 divided by 27, and that gives us 1.49. Take the 28.4 and divide it by 27, and we'll get 1.05, and 42.2 divided by 27 will give us 1.56. Now we can't have 1.5 protons, so we're going to need to multiply all of these numbers by 2. So 1 times 2 will give us 2. 1.5 times 2 will give us 3. Times 2 will give us 2 here, and times 2 will give us 3 here. Remember, these are the relative number of protons, not the actual number. A lot of times we'll be given a formula, and then you can figure out how many actual protons there are in your compound. So let's look at some more examples. Here we have a signal that only gives us 2 different signals. We're given the molecular formula, so we have 10 hydrogens. Okay, so we know that. We'll need to take the smallest and divide both of them by that number. It's going to be 32.5. That'll give us 1. And 48 divided by 32.5 gives us 1.47. So multiply times 2, that'll give us 2. Multiply times 2, that gives us 3. So the relative numbers are 2 to 3. But since we know that we have 10 hydrogens, this must be 4 protons. And this must be 6 protons. So that it adds up to 10. Here's a compound with 10 hydrogens. Determine the number of protons giving rise to each signal. So again, we find the smallest number, 33.2 divided by 33.2 will give us 1. 48.4 divided by 33.2 will give us 1.5. This gives us 33.3 divided by 33.2. That's going to give us 1. And 48.7 divided by 33.2 also gives us 1.5. So we're going to be multiplying by 2. And this first peak will be a relative 2. Second peak will be a relative 3. Third peak will be a relative 2, and the fourth peak there is a relative 3. So 2, 3, 2, 3. We need 10 altogether, and that adds up to 10. So that is the number of protons that arises from each signal. And here's our last one. We're going to divide all of these by 17.1. If we divide 17.1 by itself, we'll get 1. If we divide the 87.1, we get 5. And this is 18.7 is going to be functionally 1. And down here, the 51.3 divided by 17 is going to give us a 3. Okay, so the molecule has 10 protons, and we've got 10 protons, so we are good. What do you think these are? You think maybe we've got a ring that has something off of it, and these are the 5 hydrogens of that peak that are de-shielded by being in that ring. The next thing we'll be talking about is multiplicity.